Good evening, everyone. Welcome to the GATE 2026 Booster Series. Now, we are going to discuss about the geotechnical engineering and especially NAT and MSQ questions from the main topics. So, myself, Pawan Kumar, and I have been teaching the geotechnical engineering for the past 9 years in ACE Engineering Academy. So, let's see about the questions first as MSQ, and over the period of time, we will be discussing about the NATs also. So, now you see, which of the following is /R correct? So when it is mentioned is /R correct, that means that that turns into the MSQ type. So multiple select. Now void ratio for a spherical particles with a cubical arrangement is 0.91. If you see in the case of the soil particles, the soil particle shape can be any shape. But if you are going to turn into a spherical shape, and especially if you are going to arrange in a cubical pattern, so in the case of the cubical pattern, it's a loosest packing. So whenever it is a loosest packing, then for this, the void ratio, maximum void ratio comes as 0.91. That doesn't mean void ratio is always a maximum of 0.91. This is suitable for the spherical particles. But if you take a gravel, you take a clay, so in the case of the clay, particles are flaky particles. In the case of gravel, angular particles. So as the particle shape changes, the arrangement will changes, the void ratio is also going to be changed. For spherical particles, yes, this is correct. So statement A is correct or option A is correct. Maximum void ratio is limited to 1. No. So you know void ratio is VV by Vs, right? Now, sometimes for a given soil, voids may be more than solids. Sometimes voids may be less than solids. So void ratio can be greater than 1, can be less than 1. What void ratio cannot be 0? Because the meaning of void ratio 0 is voids should be 0, which is not possible. So void ratio is not limited to maximum of 1, it can be more than 1 also. Void ratio for a fine grained soil is more than coarse grained soils. Yes. Why? In case of the fine grained soils, as the size of the particle is very, very small, the number of voids in a given volume is more. And the total volume of voids for a given soil is more. So if you compare a coarse grained soil and a fine grained soil of the same volume, in fine grained soil, the volume of voids for that given volume is more compared to the coarse grained soil. So always void ratio is more for fine grained soil. So the correct answer is option C. And always void ratio is more than porosity. Yes. So no, you know E is equals to N by 1 minus N. So obviously void ratio is always greater than the porosity. So now the statement number D is also going to be correct. So in this question, A, C and D. So the correct answers are A, C, D. Let me check. So how many of you people are given correct answers? Okay. Okay, some of the people are giving correct answers and some of the people are saying that A and D only. Some people has given an A, B, C, D. Mind you, in the case of the MSQ type, if you miss one option, you will be out of coverage area. No matter how hard, no matter how smart you are, you miss one option, you will be out of coverage area. So you have to understand that each statement clearly. You have to read that statement clearly, analyze, understand, and then answer. So now moving towards the next question. In clays, the tendency for the particles to flocculate will increase one or more of the following. You know that in the case of the clays, there are two kinds of structures, dispersive structure and flocculated structure. Now, the tendency for particles to flocculate, which means they're asking about the flocculated structure. So, you know, in the case of the flocculated structure, most of the arrangements are going to be the edge to face arrangement, right? Now, that arrangement will increase on one of the or more of the following. Again, one or more means this is MSQ, right? The total potential energy between particles, they approach each other decreases. Look, whenever the flaky particles comes closer, now what happens is, when there comes closure, if their energies are going to be increases, what will happen is they will ripple out. So when the particles moving together, if the particles energy is increasing when they move on to each other, then what they will do is they will ripple out. But whenever the particle energy is going to be decreases, they come and they settle by means of attraction. Which means when particles are going to become closer, if their potential energy increase, particles will repel. If the potential energy decrease, the particles will attract and they will undergo flocculation. So which means the total potential energy between particles they approach each other decreases as. So now that's correct only. And second one is concentration of the electrolyte. Yes, obviously the more the positive negative charges, the more the positive electrolyte is nothing but here the cations and anions are there on the clay particles, right? So on the on the edges there will be the positive, on the face there will be the negative. When the concentration of these electrolytes are going to be more, obviously attraction is also going to be more. So true. And even pH of the water. When the pH when the pH of the soil is also going to be more, then that also tends to more attraction. Option C also. Now see the D. Option D is exactly opposite to the option A. So we have to eliminate this. And this one question where we haven't seen this type of analysis also. This is one of the new question, a good question. So that can be asked for the MSQ regarding to the flocculated structure. Now you can frame the same question for the dispersed structure also. Okay. Now let's say this. Which of the following statement is /R correct regarding compaction of the soil? Now this time coming to the compaction of the soil. So in the case of the compaction, maximum bulking of sand occurs at a moisture content of 4 to 5%. Yes. In the case of the sands, when you add a water content at low moisture content on the particles, instead of water filled in the voids, the moisture will stick over the clay. The moisture will stick over the sand particles. That leads to apparent cohesion, and this apparent cohesion is due to the capillarity. So now at low moisture content, this moisture will hold on the particles, and these will not allow the particles to come closer. When it will not allow the particles to come closer, you cannot compact more soil in the volume of the mold. You cannot compact more soil in the given volume. So when you cannot compact more soil, then that is nothing but the bulking of the sand. So bulking of sand occurs at a maximum moisture content of 4 to 5. That's true. And again in clays, maximum dry density or maximum dry density tends to decrease as the plasticity increases. So if you look into the curve of water content and the dry density, so the more the plasticity of the soil, it can absorb more amount of water. You know, when it absorbs more amount of water and the particles absorbed water will be more. And when the plasticity is more, particles can absorb more water. More water means you are compacting less soil. So which means the graph will be fall somewhere over here, where OMC is very high and dry density is very, very less. In clay, maximum dry density unit weight tends to decrease as plasticity increases. That's also true. Uniform sands leads to lowest dry unit weight values. Yes, in the case of the uniform sand. So whatever the bulking of sand that will occur in well-graded sand, but in the case of the uniform sand, if you draw, the graph would looks like this in case of the uniform sand. So uniform sand will be the one that is having a least dry density. That's also true. Cohesive soils have generally low values of OMC. Does it? You see the graph over there? There is a plastic clay, cohesive soil. Does it have a large amount of OMC or a small amount of OMC? It has very high OMC. But it is mentioned that cohesive soils have generally low values of OMC. No, it has high values of OMC. So what are the correct answers again here? A, B and C. Okay. Now move on to the next question. Which of the following statements is /R correct regarding quicksand condition? So let me see how many of you will solve this. Let me post your answers in the chat section. Post your answers. Post your answers, please. Okay. This is silts, not silts. That is silts. Yes. Some of the people are giving answers as A, B, C, and some of the people are given as A and C. Okay. Yes. So now Let's see, some of the people has given the correct answers A and C, but some of the people has given A, B, C also. Now, let's say this. Which of the following statements is slash are correct regarding quicksand condition? So, sand water density is roughly twice of the denseness of water. Yes. At a quicksand condition, the gamma sand is still 20 kilonewton per meter cube, right? So, this is approximately 2 times of unit weight of water. Yes, that's true. Now, second one, quicksand can suck human beings and animals. You see, in most of the movies, you will be observing that at the end of the movie, the villain or some characters, so while they are traveling in a forest, somehow they will be end up in a quicksand and they are going to be submerged in the quicksand. They will be dragged into the quicksand or they will be sucked into the quicksand. So that's what we see in the movies also. But in reality, it's not like that. Actually, quicksand, that sand is much more viscous than water. In water, you jump, you are going to drown. But quicksand is roughly 2 times denser. It is more viscous. Then why, sir? Then I have seen that some of the cases where people has drenched into the quicksand. That is not to the quicksand. That is the persons who fell into that quicksand with a fear, where they get scared and they tried more and more and more. As it is more viscous, then it will touch us or it will attach it to the body and that will pull down. So what one person, if he or she stuck in a quicksand condition, what they have to do is first be calm, make sure yourself calm, then you can drag yourself slowly by rotating your arms, by moving your legs. But fortunately, you will never ever suck into the quicksand because it is highly viscous in nature. So quicksand will never suck human beings and animals on its own. But if that animal or a human being, we try to move in all the directions with a scare, then they are going to be get tired and they'll get suffocated, then only they will die. So humans. Now the quicksand condition cannot suck a human being. Some of the people are giving answers as quicksand can suck human beings. So I hope you have very good movie knowledge, but it's not the reality. Now high artesian pressure in sands is one of the important reasons for the development of quicksand. Yes, whenever artesian pressure comes into existence, effective stress is equals to total stress minus artesian pressure. When the artesian pressure is going to be more, there is a high possibility that effective stress can be zero. So now that's also one of the reason. Now quicksand occurs in fine silts and sands. Does it? No. Quicksand occurs in fine sands and silts. What about fine silts and clays? They'll be having some cohesion. So whenever the cohesion comes into existence, no matter even if effective stress is zero, shear strength will not be zero because some certain amount of cohesion is there. So this is also D correct. Now what are the correct answers? A, C and sorry, this is incorrect. A, C only. So the correct answer is A and C. Okay. Now see this question again. This is MSQ, but this time we are doing in terms of the numerical point of view. We have seen some conceptual questions with respect to the MSQ, and you can also expect that MSQ as a 2 marks with respect to the numericals also. Let's see this. In the following figure, soil X has a permeability of 4 in 10 to the power of minus 3. So Kx 4 into 10 power of minus 3 centimeters per second. Okay, and head loss in soil X is 9 times of head loss. Head loss in soil X is 9 times the head loss in soil Y. Let me check this. Sorry, this is head loss in soil Y. Head loss in soil Y is 9 times the head loss of soil X. So head loss in soil Y is 9 times of the head loss in soil X. Which of the following statements is a slash or correct? You see here the elevation. This is in terms of the centimeters. The elevation is given. So this is a datum 0, 10, 20, 30 and 40. If you observe here carefully, what is the difference between the water levels? That is nothing but H. So whatever the total head loss is equals to 40 minus 30, which is 10 centimeters. That head loss is equals to Hx plus Hy, which is equals to 10. So Hy is 9 Hx, then 10 Hx is equals to 10. So what is this Hx value? The Hx value is equals to 1 centimeter. If you know the hx value is 1 centimeter, then hy value is nothing but how many centimeters? 9 centimeters. But what is the question they're asking, sir? The permeability of the soil X is. You see, they have given the permeability of the soil. So now they're asking about the permeability of soil Y, not X. Yeah. So this is Y, the permeability of soil Y. What is the permeability of soil Y? They have given the permeability of soil X. If you observe here carefully, that's a constant head apparatus condition where you are keeping one soil on other. So there is a flow perpendicular to the bedding planes, right? So as flow is perpendicular to bedding planes, you know the flow rate Qx and Qy both are same. Velocity is also same. When velocities are same, then Kx into Ix is equals to Ky into Iy, right? What they're asking is a Ky, right? They're asking Ky. You know Kx, and what is Ix? Kx is equals to Hx by Lx is equals to Ky into Hy by Ly. But what is Lx and Ly? Lx, this is nothing but Ly, and here it is nothing but Lx. So Lx and Ly, 10 minus 0, 20 minus 10. Lx is 20 minus 10, 10 centimeters. Ly is 10 minus 0, 10 centimeters. So which means Lx is equals to Ly, right? When Lx and Ly both are same, then you get cancelled. Then simply you substitute. What is the Kx value? Kx value is given as 4 into 10 power of minus 3 into Hx. What is the Hx value? 1 is equals to Ky into 9. Then the Ky is equals to 4 into 10 power of minus 3 by 9. You calculate this. Open the calculator and you can solve it. So if you solve it, you're going to end up with this answer as 4.4 into 10 power minus 4 centimeters per second, right? That's the answer. But if you see the options over here, so in the case of here, you observe what is the answer? The answer is like, where is this? Yeah, permeability of soil Y is 4.4 into 10 power of minus 3. But what is the answer? It's a 10 to the power of minus 4, not minus 3. So please, when you are seeing that, not 4.4, then you have to see about the 10 powers also. It is minus 4, it is not minus 3. So the correct answer is, A is not a correct answer. What is the correct answer? 4.4 into 10 power of minus 4. Now let's see the remaining parts also. Quantity of flow is 14.4 centimeter cube per hour. They're asking quantity of flows also. You know they have given the area, right? And as the flow is perpendicular bedding plane, Qx, Qy, everything is same. So Qx is equals to, let's take it as Kx into Ix into area. What is the Kx? It's already there. 4 into 10 power minus 3 into Ix. What is Ix? What is Ix? Ix is nothing but Hx by Lx, right? So Hx is given as 1, Ix as a 10 into 10. This is all centimeter cube per second. Because the Kx value is given as 4 into 10 power of minus 3 centimeters per second, right? Now 10 will get cancelled, but this is 4 into 10 power of minus 3 centimeter cube per second. What we are asking is in terms of hour. So per hour, multiply with 60, multiply with 60. So what is this Qx value? What is the Qx value? The Qx value, you solve it. It will comes as 14.4 centimeter cube per hour. Yes, that is true. That's correct only. So now quantities of flow is 14.4 centimeter cube per hour. So first one is incorrect. Second one is correct. Now see the next one. pressure head of water at elevation level 10 meters is. What is the pressure head of water at elevation level 10 meters? See, at elevation level 10 meters, if you observe carefully, at elevation level 10 meters, the flow is upward. Na? At elevation level 10 meters, the soil already lost a head of HY. So now, if I insert a piezometer here, up to what head water level rises? Will it rises to the original level? No, it will rises to somewhere over here. So you know what is this head loss? What is this head loss, right? At elevation 10, already water passed through soil Y. So what is that head loss? That head loss is HY. So now, come on, this entire head is nothing but what? Pressure head. That entire head is pressure head. Now how to find out this pressure head? So the pressure head is nothing but from the top to this point. What is the elevation here? 40. What is the elevation here? 10. 40 minus 10, 30. But out of the 30, head is going to be lost by HY, right? So now, at elevation level of 10 meters, at elevation level of 10 meters, so pressure head is equals to 40 is the total elevation minus 10 minus HY. So which means 30 minus, what is the head loss in Y? Head loss in Y is 9 meters. 9, answer is 21 centimeters. Is it correct? Pressure head of water at elevation 10 meters is 21 meters. Yes, that's also correct. Now what is the piezometric head at 20 meters? The piezometric head at 20 meters. They're asking at the piezometric head at 20 meters is what? 21 meters. Now we have to see at 20 meters. At 20 meters means a complete head loss, na? So at 20 meters means whatever the head that is going to be lost over here. So if you observe carefully, how much head is going to be lost? In the case of the soil Y 9 and soil X is going to be 1. Now if I insert a piezometer at the 20 meters, they are asking piezometric head. Now up to this point, there must be some pressure head, right? It will rise up to this water level. That's going to be the total head loss, right? Now, what is this pressure head? This pressure head is nothing but from the 40 to the 20, how much is there? 40 minus 20, 20 minus head loss. So, at elevation level 20 meters, what is the pressure head? 40 minus elevation 20 minus total head loss. What is the total head loss? Hx plus Hy. So 20 minus H value is how much? 10. What is this value? 10 meters. But that's the pressure head. What we want is what? Piezometric head at 20 meters. Now what is the piezometric head? Piezometric head is pressure head plus datum head. So the pressure head is 10 plus datum head. What is the datum head? The datum head is from 0 to 20. The datum head is from 0 to 20. So plus 20. What is the answer? 30 meters. Though it may take time over here, but when you are solving, you will be able to get it done by seeing the figure itself. So, but what is the mention over here? 21. No, it's not correct. So, what is the correct answers? The correct answers are B and C only. So, I hope that you understood the MSQs over here. We have been solving different models also. Okay. So, now, yeah, moving forward. Let's see this question. Come on, answer to me this question. Post your answers, please. Come on, post your answers. Okay. So, some of the people are posting. Yeah. Avinash is posting option A and D. Narsimha is posting that answers as A, B, D. So, some people are posting answers as a B and C. Now, let's check what are the answers that are going to be for this one. Okay, most of the people are posting as a correct answers only. But now let's see. So, which of the following statements is a /R correct? So, liquidity index can be a negative value. Yes, it can be a negative value. You know that liquidity index is equals to W minus WP by IP. whenever the water content, natural moisture content is less than plastic limit, then liquidity index is less than 0. So which is mean negative. So it can be negative. But what about the plasticity index? Cannot be having a negative value. Yes. What is the plasticity index? WL minus WP. Always liquid limit is greater than plastic limit or equals to plastic limit. So the plasticity index will never be less than 0. So this is also correct. Now if consistency index is greater than 1, then the soil is in plastic state. No, whenever the consistency index is greater than 1, soil is very stiff. It can be solid state or it can be semi-solid state. So whenever the soil enters into the plastic state, the consistency falls less than 1. So this is incorrect. And if activity of a soil exceeds 1.25, it is said to be expansive soil. Generally, when activity is greater than 1.25, we call that as active soil. And one of the example for the black cotton soil is nothing but the expansive soil, right? For black cotton soil, the activity is somewhere around 7.8. The activity is somewhere around 7.8. Okay. So now coming to this. So this question is an NAT. Now we'll solve some of the NAT questions. We have done some MSQs. Two samples of a soil were subjected to the shear test. The results were as follows. So now two samples of soil samples were subjected to shear test. The results were follows. Now the results were like by conducting the triaxial test, we got two specimens. So minor principal stress is there and deviatoric stress at failure is given 75, 150, 105, 190. If further sample of the same soil was tested under a minor principal stress of 225. So in the third specimen, if the minor principal stress is 225 kilopascals, what they're asking is what is the total axial stress, which means they're asking sigma 1. But to find out this sigma 1, you need to find out what? From plastic equilibrium condition, you need to find out the C comma phi. Because this soil is not sand, this soil is not clay. So you need to find out that sigma 1 is equals to sigma 3 tan square alpha f plus 2c tan alpha f. How many unknowns are there? 2. 1 c, another one alpha f. Alpha f is 45 plus 5 by 2. As I have two data, I can create two equations. I can find out the two unknowns. So first data 1, here itself I can write what is sigma 1 also. What is sigma 1? Sigma c plus sigma df. 75 plus 105, it's going to be 180. 150 plus 190, here it is going to be 340, right? So now let's substitute this in the plastic equilibrium condition. Okay, so sigma 1, 180, sigma 1 is equals to sigma 3, 75 tan square alpha f plus 2c tan alpha f, and 340 is equals to sigma 3, 150 tan square alpha f plus 2c tan alpha f. Now you see here, this is equation number 1 and here equation number 2, 2 minus 1, right? So now 340 minus 180, so this is going to be 160 is equals to, what is this? 75 tan square alpha f. Anyways, this will be gets cancelled, right? Now what is tan alpha f? Alpha f is equals to tan inverse of square root of 160 by 75. You send the 75 to the other side, 160 by 75, square to the other side, root. Now come on, solve this. What is alpha f? So come on, solve it. Solve it. What is alpha f? You will be getting that alpha f as a 55.59 degrees. Alpha f is 55.59 degrees. Okay. So once you know this alpha f, then you can find out. You just need to keep that alpha f only. Don't worry. So you just keep that alpha f. Now once you know the alpha f, from equation 1, I can write down 180 is equals to 75 into tan square 55.59 plus 2c into tan 55.59. So what is the C value? Come on, you solve it. Solve. C value is a 6.89 kilopascals. 6.89 kilopascals. Okay. So C value is equals to 6.89 kilopascals. Okay. Now you see the third one. So we got the C value and we got the alpha F, right? So now for the dot data, for data point 3, now I can write down what I want is sigma 1 and what is required is sigma 3, means what we require is sigma 1 and what is given sigma 3, 225 tan square alpha F again 55.69 plus 2 into C 6.89 into tan 55.69. So I hope you get it. Come on, solve this. If you solve this, you will be ending with 499.73 kilopascals. So the major principal stress is 499.73. You go back, but it is clearly mentioned round off to the nearest integer. So what is the nearest integer for this? The nearest integer 499.73. The nearest integer is how much? 500 kilopascals. The correct answer is 500 kilopascals. Okay. So that's how you are going to solve this question. It's an NAT type where it is from the shear strength topic. Okay. Next, see this question. So again, this is MSQ question where I have given multiple data, a lot of data over here. Again, this is a very one good question which will cover all the topics of the retaining walls. So see this question. A 3 meter wide rectangle wall of 6 meters. A 3 meter wide rectangle wall of a 6 meter side. So I have given the width of the wall and I have given the height of the wall. Retains a backfill of dry granular soil. Granular soil is nothing but sandy soil. And the weights, unit weight is given as 1.85 gram per cc, which has a level surface. So now you see here, this is a retaining wall of width 3 meters, height is given as 6 meters. Now it is retaining a granular soil. Granular soil means C value 0 and dry unit weight 1.85 gram per cc. Okay. When there is no surcharge above the fill, there is no surcharge. The overturning moment caused by the total active pressure at a point at the base of the wall is given as 14.5 ton per meter length. What is the meaning of overturning moment caused by total active pressure? Look, this is a sea soil and there is a phi, right? What is the meaning of cohesionless soil? The cohesionless soil will cause a active pressure force like this, right? So what is this bottom? Ka gamma h. That will create an active force of Fa at a height of h by 3. And what they mention is, so in this case, the overturning moment caused by the total active pressure. Who is causing the overturning moment? The active force will cause the overturning moment. And what is that overturning moment? That overturning moment is MO is nothing but Fa into H by 3. So that value is given as how much? 14.5 ton meter. 14.5 ton meter. Okay. Now the specifications permit certain amount of the uniformly distributed surcharge. So beyond this, you can permit certain amount of the surcharge, but state that surcharge must not increase overturning by more than 65%. So if you apply a surcharge, obviously due to the lateral pressure there is some overturning moment, but if you bring the surcharge after surcharge, you can see there is a rectangular pressure distribution, and you can see there is a triangular pressure distribution. So whatever this we just discussed this. Let's take it as FA1, and this one is the FA2. You know this is Ka gamma H, and you know this is Ka into Q. If you apply a surcharge of Q, what they mention? So state that surcharge must not increase overturning moment by more than 65%. Already there is a overturning moment of M naught. The surcharge should not exceed 65%. Okay, fine. Which of the following statements is /RR correct? So this is the whole data. Now let's see the questions what I'm asking you. So if you look into over here, the coefficient of the active earth pressure is given as 0.22. Is it correct? Let's check. What is the coefficient of active earth pressure? Ka. Go back. Look over here. Look over here. You know that active overturning moment is given. And what is Fa, man? Fa is nothing but half into base into height, na? Half into base. Ka gamma H into height. And multiply with H by 3. This is going to become as 14.5 ton meter. But you observe they have given the gamma as a 1 gram per cc. You know that 1 gram per cc is nothing but 1 ton per meter cube. Simply. Gram per cc is nothing but 1 ton per meter cube. So substitute. Now what I want is Ka, right? So half into Ka into 1.85 into H. 6 cube by 3 is equals to 14.5. Now from here, what is the Ka value? Okay, you solve it. You're going to get that answer as 0.218. The Ka value is 0.218. Now, they have given 0.22. So, round it to 2 decimal 0.22. So, if you round off to 2 decimal, the answer is going to be 0.22. Okay. Now, let's see the next question. The minimum weight of the retaining wall would be this much of wall. What is the minimum weight of retaining wall? So, you know that they have given the overturning moment without surcharge. For no overturning moment, I'm a wall for no overturning moment, then that overturning moment should be resisted by my weight, right? So if I say, and if I take weight is the W, then what is this lever arm? The width is 3 meters and this is nothing but how many meters? 1.5 meter. For no overturning, the resisting moment should be greater than or equals to overturning moment. Okay? For no overturning, whatever the resisting moment Mr must be greater than or equals to overturning moment. What is the resisting moment? W into 1.5 must be greater than or equals to overturning moment. What is overturning moment? 14.5, na? 14.5. So that weight must be greater than or equals to 14.5 by 1.5. So tell me this value. What is 14.5 by 1.5? For no overturning failure, what is a 14.5 by 1.5? So you calculate. It comes as 9.67. It comes as 9.67 tons. Right? That's it. So they're asking about what? Overturning. Now overturning is about what? 2. So what is the correct? What is this one? 9.67 ton per meter. Yes. This is also correct. Option B correct. Option A is also correct. Now, surcharge that can be allowed for no overturning failure. Surcharge that can be allowed for no overturning failure. Now if you see, when you must apply the surcharge must not increase the overturning moment by more than 65%. So it should not increase the overturning moment by 65%. First of all, what is the moment due to the surcharge? If you look into the moment due to the surcharge, this is the one. The moment due to the surcharge is FA2 into H by 2. So the moment due to surcharge should not exceed 65%. What is this? 65% of the overturning moment. 65% of overturning moment. So what is the moment due to the surcharge? The moment due to the surcharge is, you see here, what is this FA? FA is nothing but area, right? So yeah, area into H by 2. What is this area? FA, that Ka into Q into H. The moment is Ka into Q into H into H by 2 should be less than or equals to 0.65 times of, what is the overturning moment given? 14.5. So what they're asking is that Q. You know Ka value, we got the Ka value. What is the Ka value? 0.22. So 0.22 into Q into H 6 square by 2 is equals to 0.65 into 14.5. So what is this small q value? Come on, tell me. What is the small q value? The small q value goes as 2.40 ton per meter square. So if you see here, if you solve everything, you'll be getting that value as 2.40 ton per meter square. Is it correct? No, it is 1.9, so it's not correct. Now what is the last one? What is the total active pressure at the base of the wall after the surcharge? Now after the surcharge, what is the total pressure at the base of the wall? Ka into Q plus Ka plus gamma into H. So after surcharge, the active pressure at base of the wall is Ka into Q plus Ka gamma H. So 0.22 into 2.40 plus 0.22 into 1.85 into 6. So tell me the answer. Everybody. What is the answer? Priyanka 2.94, Chaitanya 1.56, Naveen 2.56. No, the correct answer is 2.94 ton per meter square. 2.94 ton per meter square. So now you go back, and what is the answer they have given? They have given 2.44, right? Yeah. Actually, it is not 2.44, it is a 2.94 only. 2.94 ton per meter square, it's a mistake. So the correct answers are now A, B and D. So these are all the correct answers. Now, I hope you understood. So here we discussed about the retaining wall. We discussed about the stability analysis. We discussed about how to find out the pressures. We discussed about the effect of the surcharge also, right? Now, solve this question. Try to solve this question. Come on, everyone, solve it. Come on, solve it. Some of the people are asking, sir, in the previous question, if they ask about sliding failure. So what they're asking, some of the people are asking, so if they ask about sliding failure, so in the case of the sliding failure, this is overturning, right? Once you know this, you can find out the sliding failure. The force is nothing but Fa, the resistance is nothing but mu into weight. So if you know if I give you the coefficient of the friction, then you can find out the factor of safety against sliding also. But you solve this question. Now, a square pile group of 16 piles passes through a recently filled up material. A square pile group of 16 piles. So, what is the pile group? So, now this is nothing but the 16 piles. The total number of piles are 16 and this is a square 4 by 4. Passes through a recently filled up material of 3.5 meter depth. So, what is the recently filled up material depth? LC is nothing but 3.5 meters. Dia is 30 centimeters, pile spacing is 1 meter. So, dia 30 centimeter, which is 0.3 meter, spacing 1 meter center to center. If the unconfined compressive strength of cohesive material is 50, so what is the unconfined compressive strength of cohesive material is 50. 2 into Cu is equals to 50. Then what is Cu? 50 by 2, which is 25 kilopascals. Now, what is the negative skin friction? They're asking of the pile group, what is the negative skin friction? And there, what is the unit weight? The unit weight is given as 18 kilonewton per meter cube. See, they have given the pile group, they have given diameter and have given you the spacing. And I'm asking you what is the negative skin friction of the pile group. So, whenever we discussed about the negative skin friction of the group, then you need to find out what is the negative skin friction when they act as individual and what is the negative skin friction when they act as a block. Once we know those, then only we can understand out of those two, we'll be taking larger because negative skin friction reduces the load carrying capacity. So, we have to take out of these two, whichever is more critical, means larger. So, first find out the negative skin friction of individual. So, the negative skin friction of the group acting as individual is whatever the total number of piles into, then what is the negative skin friction of individual pile? Alpha into C bar into pi d into up to what length? LC. Alpha into C bar into pi d into LC. So, what is that N value? The N value is nothing but 16. And they mentioned take alpha as how much? 1. 16 into 1 into, we got C. As it is a homogeneous, average and Cu both are same. 25 into pi into, the D value is given as 0.3 meters and LC, that's a 3.5 meter, right? So, you solve this. You'll be getting a value of 1319.47 kilonewtons. 1319.47 kilonewtons. Okay. So, that's about the group. But when you are acting as an individual, means this is about the group acting as individual. But when you talk about the group acting as a block, then you have to think about that. So, now alpha into C bar into, now as a block, I have to find out the surface area. What is the surface area of the block? Perimeter of the group into LC. Apart from that, you have to find out the weight of the soil in that zone also. Weight of the soil in that zone also. As alpha is equals to 1. So, first of all, this C bar into PG into LC plus what is the weight of the soil? Unit weight into volume. What is volume? Area of the group into LC. So, first we need to find out the perimeter of the group and area of the group. Now, you know there are 4 pile groups, right? So, and as it is a square, B naught is equals to L naught is equals to how many piles are there? 4 piles. Then how many spacings would be there? 4 minus 1 into spacing plus diameter. So, what is the spacing? 1 plus diameter 0.3. So, this is going to be 3.3 meter. And now, whatever the negative skin friction of a group acting as a block is equals to C value is 25 into perimeter of the group. Array, now as it's a block, perimeter is nothing but 4 times of the dimension. Na? 4 into 3.3 into LC. What is LC? That LC is nothing but 3.5 plus what is the gamma? Gamma is 18 into area of the group. So 3.3 square into LC. What is this LC? That LC is nothing but again 3.5. So solve this out. If you solve it, then you will be getting this value as 2072.07 kilonewtons. 2072.07 kilonewtons. Now you have to see out of these two whichever is a bigger one, that one you have to consider, right? So then the negative skin friction of group is larger value. So what is that larger value? That larger value is 2072.07 kilonewtons. And if you observe, I am asking you round up to 2 decimals, right? So the correct answer is 2072.07. So this is a question from the foundations, which is a deep foundation. See, we covered the topics of the index properties. We covered the topics of the permeability. We covered the topics of the effective stress. We covered the topics of the, in the case of the shear strength, we covered the topics of the retaining walls, we covered the topics of the deep foundations. Still, shallow foundations and consolidation is left over. We'll see that questions also. Now, see this question. Yeah, these are, which is nothing but the bearing capacity, which is a shallow foundations. Now you see a 2 meter wide strip footing. So whatever the width is given as 2 meter, strip footing 1.5 meters, depth is given. Constructed in a pure clay deposit, estimates the safe bearing capacity. So they have given the safe bearing capacity as 180. You know, in the case of clay, how to find out the safe bearing capacity? Fine. Now that's okay. A loading test was conducted on with 300 mm circular plate. Okay. Now the dia of the plate is circular plate. It's not a square or strip. It's a circular plate at a depth of 1 meter below the ground surface. Now the test is conducted not at same depth, it's a different depth. The water table is located at a depth of 5 meters below the ground level. Array, the width of the circular plate is 0.3 and depth is 1 plus 0.3. The maximum depth of water table is depth is 1, width is 0.3. So the shear zone is up to 1.3 only. But water table is 5 meters below the surface, so you can neglect the effect of water table. Then the load at which a plate can fail. So below the ground level, then the load at which a plate can fail. So they are asking the failure load. What is the meaning of failure load? Failure load is nothing but ultimate bearing capacity, right? What is that? Ultimate bearing capacity. You find out the ultimate bearing capacity, you will find out because at a failure, gross pressure is nothing but ultimate failure load. Gross pressure is nothing but the ultimate bearing capacity. But to find out that, you require the properties of the soil, right? So let's see from the given data. First, they have given the strip footing and width is given as 2 meters, depth is given as 1.5 meters, and as it is a safe bearing capacity is estimated as 180 kilopascals. 180 kilopascals. Now, if you see this safe bearing capacity is a net safe plus gamma d. What is net safe? Net ultimate by factor of safety plus gamma d. In case of the clay, the net ultimate bearing capacity is CNC by factor of safety plus gamma d. That's it. And as it's a Terzaghi, now you have to find out that NC value as 9, right? What is the Q safe? 180 is equals to C value into 5.7, not 9. For shallow foundations 5.7, for deep foundations 9. By what is the factor of safety? The factor of safety, yes, the factor of safety is considered as how much? 3. Okay. So 3 plus gamma, the unit weight of the soil is given as how much? 19, same soil, 19 into 1.5. So find out the C value. If you find out the C value, then C value will come as 79.74 kilopascals. So once we know the C value, then you are going to conduct the plate load test. So whatever the plate load test that is conducted on the same soil, but this time it is on a circular plate, right? Yes. So in case of the circular plate, you know that at a failure, the ultimate bearing capacity is equals to ultimate cube, the maximum gross pressure. The gross pressure at failure is equals to ultimate bearing capacity. So you find out the ultimate bearing capacity. For circular plate, what is the ultimate bearing capacity? 1.3 CNC plus gamma D in Q plus 0.3 gamma B N gamma. But as it is a plate, then I have to take B as a BP. Okay. Now, come on. Anyways, whatever it is, as the soil is a clay, N gamma is how much? 0. NQ is how much? 1. Simply you find out the QU. The QU is nothing but failure load by BP square. So what is the BP square? Circular plate. So the circular plate is given as 0.3 meters, right? So 0.3 meters square is equals to 1.3 into C came as 79.74 into 5.7 plus gamma 19. But the test is conducted at what depth? 1 meter. 1 meter. So you can find out the failure load or the maximum load that the footing can take before failure. So what is this load? Yes, and one more point to be mentioned. See, this is a plate load test. In the case of the plate load test, you should not take the gamma D value, because in the case of the plate load test, I miss this point. In the case of the plate load test, will there be any surcharge? No surcharge, right? In plate load test, you are going to keep the plate over here. There is no surcharge effect. There is no surcharge effect. Please do this one, this point. Now, you are going to remove this one also, as there is no surcharge effect. So this will be 0. Now if you find out what is the load at a failure point, the load at the failure, that comes as 41.76 kilonewton. We can also say it as 42 kilonewtons. So now that rounded to the nearest integer, they are asking rounded to the nearest integer. So the correct answer is 42 kilonewtons. Okay. Now, the one topic that is left over and we haven't covered it is the consolidation test. Now, so this is the last question for this session, where we covered most topics. We covered shear strength, we covered deep foundation, we covered shallow foundation, we covered the shear, effective stresses, permeability, index properties and engineering properties also. So now with this, we'll be winding up the session. So consolidation test was done on a representative sample taking from a layer of clay 4 meters thick, which is located between two layers of much pervious soils. And it was found that the average value of CV, see, the clay is present between two pervious soil, which is a double drainage. And the average value of a CV for that clay is given as, what is the CV value given? 5.25 into 10 power 4 centimeter square per second. A building was constructed above the layer due to increase in the vertical pressure. So definitely when you construct a building, that will cause some pressure. Due to that pressure, the building began to settle. Find out the time it will take for 30% the ultimate settlement to occur. Find out the time it will take for 30% the ultimate settlement to occur. What is the ultimate settlement to occur? So now 30% of the ultimate settlement to occur. The meaning of 30% of the ultimate settlement to occur is S is equals to 0.3 SF, which means the degree of consolidation is 30%. Right? The meaning of settlement as 30% of the ultimate means the degree of consolidation is 30%. For this, what is the time required? Now, if you want to find out the time, I have to use time factor, right? What is the time factor? TV is equals to CV into T by D square, right? I have already CV, and as it is a two layers of the much pervious layer, so it's a drainage path. So it is a double drainage. As it's a double drainage, D value is equals to H by 2. What is H given? 4 by 2. That's going to be 2 meters, right? 2 meters. Diameter is, the drainage path is 2 meters. So I know drainage path, I know CV. If I want T, I want to find out TV. And TV is a function of what? Degree of consolidation. So instead of giving degree of consolidation directly, what I'm asking you is, well, find out the time it will take for 30% of the ultimate settlement. Okay. So now as U is equals to 30%, which is less than 60%, na? Then what is the TV? Pi by 4 U square. Pi by 4 into 0.3 square. Pi by 4 into 0.3 square. If you solve it, you'll be getting this one as 0.071. Now once we know the TV, then you can find out the CV. So now our time factor TV is equals to CV into T by D square. We require the time, na? Time is equals to TV into D square by CV. What is the time? TV is 0.071 into D square, which is 2 square, by CV. What is the CV? 5.25 into 10 power of 4. That is a centimeter square. But I want in terms of what? Meter square, right? So 5.25 into 10 power of 4 centimeter square. 10 power of 4 centimeter square converts to meter square. 10 power of minus 4. And now this everything is in terms of what? This everything will come in terms of seconds. Because this is units of seconds, na? But I am asking you in terms of days. So this is in terms of seconds. Now you know that 1 day is equals to 86,400 seconds, right? So now if I want in terms of days, divide with 1 by 86,400. So come on everybody. What is the time required in terms of days? What is the time required in terms of days? So that time will comes as 62.61 days. Okay. So 62.61 days. Now they're asking the days. Now you got to know. So to undergo the consolidation settlement of 30%, it takes 62.61 days. So that's about the consolidation. See, I have taken the topics and I have taken, most of the topics, and I have touched the topics in such a way, something new that you are able to see compared to the classroom practice questions or previous gate. Okay. So I hope you understood this session well, and this session made you to revise some of the core topics of geotechnical engineering. So I wish you all the best for your examinations. That's all for this session.